Everyone, I welcome you to my channel. Today I'll be solving this maximum depth of the binary tree. This is the second question of the tree, like in the blind 75, and the topic is tree. Inside topic, this is second question, and we have total 11 question in that in the topic or in tree section. So first question is amazing. Let's solve second question. It's very easy question, and see 13,000 people have liked, and I again showed up to you. Thanks you guys. I'll show you until I don't get a job. Until I get job into big tech company. Um, this is my motto to myself and to you as well. I will show you on the YouTube until I get the job. So let's solve this question, right? So maximum depth of the binary tree. What is saying that given the root of the binary tree, return this maximum depth. Basically it's saying it's send the height. What is the height? So for this tree you see here, for this tree 3 9, height is 2 here, right? Let's make maximum. See 20 and 15, this height is 3. So the max depth is 3. So you see, we are not traversing you are not doing a row level traversal here like 920. You have to find depth. So you have to find depth. We have to use DFS, right? So DFS I'm using here. I'll be using here. So first, just that's I will write here DFS, a function DFS, and what I'll do here, it will point it. First parameter is self. Second parameter is root, and third parameter is val. Val basically the count current depth. It tells current depth. It will return a int. So it is definition int, right? So if root is equal to null, agar if root is null, then if not root, return val or count. I would say count is the better name. Count. uh, else else uh, else what I'll do here, I will go to right and go to left, and max of both I will return. So return max of both. DFS of root dot left, comma, count plus 1, right, comma, DFS root dot right, comma, count plus 1. So it will go to root dot left. Consider the case here, for the beginning count is 0, right? So it is going to root dot left, but root is not null, right? Root is not null. So what will do here, it will go to the DFS root dot left. So root dot left count is equal to 0 plus 1, that is 1. So it will go to 1. So I found that 1 is the max height till now. So I'll go to left. So left is 9. It's also not, its root is defined. So again it will go to the left of this root 9, that is undefined, right? So till here count is 2, right? So it is undefined, then it will return the count. So for this particular 9, it is returning 2 now, and for 9 to 3, right? Now for 3 left is done. Now it will go to right. This will perform the same operation on the right part. Okay, so visualizing here is very difficult, but this is how it works. Like you go to left, and whenever we find a node is exist, we increment the count. That's it. This is very simple question, and just I will return here DFS root, and for the first time count will be 0. So to call the DFS, I have to do self.dfs to here also. To call itself also, you have to do self.dfs, and it is as simple as that. This is the simple question. Let's hope that I don't get any bug. Yeah, it passed successfully. Got it, right? So this is a very easy question. So I'll try to do a second question in front of you as well. So what is second question in the tree section? Same tree. It's also easy question. So I will paste here. Same tree question. So what is saying here, I've solved already. I'll explain you. Given a root of the two binary tree p and q, write the function to check if they are same or not. So we can do this using by bfs dfs, both the case, right? I will use dfs because dfs very easy to solve. So I'll write dfs. To check first we have to write root case as well. So we will define dfs. So basically what we have to do, we'll do dfs, right? So we have p q, two node, right? If p dot left, if p dot val not equal to p dot q dot val, agar both are not equal, then we'll return it, right? Otherwise we'll go to the left of the tree for p and left of the tree for q as well, right? And again we do comparison. So we can do bfs dfs in the both way, but I will prefer doing dfs. It is like less line of code I have to write. So dfs, it will point to self, like self, the first parameter we have to add, I don't know why, but we have to add. I'll read it out. And second parameter is q, right? And it will return the boolean, now that's it. That this is the case we have to check. If p exists and q exists, q and p both exist, and p dot val not equal to q dot val, then return false. If both exist but p dot val is not equal to q dot val, I will return the false. If both does not exist, if both, either one, there is a chance that either one of them is gone, like p, for the p we don't have to, for the q we have to. So if in that case also I will return this false, false. So if p is there but and not q, if this is false, or q is there but not p, if, if either one of them is done, like either one of them don't have next root, I will return false in that case also, right? uh, Two cases satisfied. Now I'll check here. If p dot val is equal to q dot val, if both are equal, return true. Otherwise I will return self dot dfs p dot left comma q dot left, or self dot dfs q dot left, sorry, p dot left comma q, p dot right comma q dot right. And this is the problem, return dfs p comma q. That's it. So what is doing here, if one of them is, if p available but pq is not available, p is available, like consider the two is available here but q, this two is not available, in that case also I'll return false. Or q available, this 2 is available but p is not available, this 2 is not available, I'll return false in that case. If p and q both are available, 2 and this here and here both are available, but p dot val not equal to q dot val, in that case also I'll return false, right? If p dot val is equal to q dot val, if both are true, if both are true, then I will return true. No, if both are true, it's okay, right? I will go find next until we don't find the, until the this tree is done. So what I'll do here, if p, if not p, if both are not defined, if not p and not q, it means technically we have reached to the end of the end, like q dot left is not defined, p dot left is not defined, q dot left is not defined. That means we have reached um, leaf node, like we have reached the bottom of the tree. And the bottom of the tree means till now we have not find any element which is not equal to each other, right? So it means that we have reached the bottom of the tree. So we will return the true. We have reached the bottom of the tree means we have not found two elements from p and q, in the same direction which is not equal, right? If that is the case, we will return true. You got my point here, right? This is the basic key. Agar if both p and q both are not exist, we will return true. Why? Because this case is making sure that we are going to the bottom of the tree. uh, we are going bottom of the tree after verifying each character or each node. If one of them is not verified, it will return false from here only, right? So this is the case I will add here, right? Let's run this code and we are done. Okay, I have to do self.dfs. Yeah, it ran here. Let's submit this code. Okay, it's wrong answer. What I've done here, output is true. How is possible? Self.dfs p.left is equal to q.left, and p.right is equal to q.right. Huh? See, p, let's verify for this test case. Why is failing? So p, for the first time, p and q both are going to the tree. Now p and q is not defined. P and q is defined here. 10 and 10 is there, right? If p exists but q not exists, but both are exist, they are also false. And p and q are equal. P and q exist and p and q value is not equal, but both are equal. So I'll go to the p dot left and q dot left. So p dot left is 5, q dot left is also 5. Q dot left is also 5 here. So so what I'll do here, I will go to the I'll go to the right, I'll go to the left. 5, p and q are both are defined. P and not q, or pq and not p. P exists and q does not exist, or q exists and p does not exist. Q exists here, right? 5. P exists here, right? 5. And q also exists, right? Yeah, return false. And p and q both exist, but p dot val 5 and 5 both are equal. Then again I'll go to the left of this particular tree. So left is null. Right is left of 5, right? Left of 5 is null. So till now we have found left tree. Now we'll go to right of the tree. The right of the tree, right of the 5. So right of the tree, right of the 5 is already there, right? Right of the 5 is null, and right of the 5 is 15. So p dot right and q dot right. So p, not p and not q. This is not true. P exists but not q. P exists not q. P does not exist but q exists. So q exists but not p. So return false. Okay. You see here, p exists but q does not exist, and P exists and Q does not exist, and Q exists but P does not exist, then return false. And here we have reached here, it means all exist. If all exist, then P dot val and Q dot val is not equal to false. But I have to, it should fail, it should return false here only, because Q dot left exists but P dot left does not exist. Sorry, Q dot right exists, P dot right exists but Q dot right does not exist. So DFS of P dot right and Q dot right, so not P not Q true, but P exists not Q. P exists, yeah, P does not exist but Q exists, Q exists but not P. So what is the wrong here? If not P and not Q, return true. If not P and Q, if P exists and not Q, Q exists and not P, return false. P dot left, Q dot left, P dot right, Q dot right. It's simple as that, but why it's again not fair? There's some minor mistake I'm doing. I am not able to figure out what is that. Uh, if not P and not Q, both does not exist, I will return true. So 5 dot right does not exist, right? बट यहाँ पे P एग्जिस्ट कर रहा है, लेकिन P एग्जिस्ट नहीं कर रहा. P एग्जिस्ट नॉट Q, और okay, let me check it like not P but Q, but not Q, P and not Q. Does it matter? Still not matter. Not P and Q, or not Q and P. Not Q and P. Not Q and P. Not Q and P. If this is the case, return false, other return true. I don't know what is the problem I'm doing here. Still failing. I don't know what is the problem. Let me ask ChatGPT what is the problem. Okay, and both should be true. Correct. Got it. DFS right and left both should be true. Then only it will work. I'm sorry. I'm very sorry. Yeah. Now it's worked, right? Let's meet tomorrow. Let's meet tomorrow. I was just not able to add here. To make it equal, we have to have both same, right? If one is the same, other is not, then it will be false, right? So DFS was returning false, but it was returning true. So one of them is true, then this whole expression is true, right? That is the problem. That was the problem. So I have changed to n, means both should be true only. I will submit it. Okay, it's already done. Now let's meet tomorrow and we'll solve another question of the tree. Thank you so much.